Hi everyone. I hope you all are doing good. So in my today's session, I'm going to explain one of the principle of solid called single responsibility principle. Basically, it comes under low level design, and this is one of the fundamental and most important principle that we should follow during our low level design of our software development. Okay, so let's start with it. So, what is it? The single responsibility principle is a computer programming principle that states that every module or class in a computer program should have responsibility over a single part of that program's functionality, and it should encapsulate that part. All of that module or class services should be narrowly aligned with that responsibility. Okay, so in simple words, a class should have only one reason to change. Okay, so when you are designing your classes, okay, or your entities basically, so you should design them in such a way that they should be cornered around one responsibility. Okay, for example, suppose I'm creating a class which is meant for handling email related operations. Okay, in that case, that email service class should contain only the responsibility associated with handling email oriented operation. Okay, it should not do anything else. For example, you have created a class called email service. Okay, so what are the bare minimum things or operations it should support? Like it should contain compose email, send email, okay, draft email. So only the things which are associated with the email should be kept inside this class. Okay, suppose if you introduce one more method in that class, for example, okay, uh, for example, if you want to put a method like sign in is basically associated with the user. Okay, a user account. So this is where you are basically violating the single responsibility principle, because user sign in is not related to email functionality or email responsibility, I can say. Okay, so that's why single responsibility plays an important role, and you should know a class should have only one reason to change, that is only the narrowly aligned functionality for which it has been created. So what are we achieving with this? First of all, quality. The product whose functionalities are encapsulated as single responsibility into their own classes always helps developers to achieve high quality unit testing or ATDD. Okay, mark this word. Okay, the product whose functionalities are encapsulated as a single responsibility into their own class. Okay, it doesn't contain anything else except it contains the functionality for which it has been created. As the size of the class is relatively smaller, agreed. For example, if I created a class for email service, it will contain the methods or functions associated with the email operations only. That's why the class is relatively smaller, and yeah, developers can do a detailed unit testing and they can achieve a good coverage, basically 100% coverage, I can say. Okay, so this that's what quality we can achieve by employing single responsibility principle. Now, concurrent delivery, the next part. So, SRP guarantees that the functionalities are split into their respective classes, thus helping developers to work parallelly on various functionalities. There is a rare chance that two developers works on the same functionality, because when we start the development, when we get the user stories, usually they are independent requirements which two developers can work parallelly. And by implementing single responsibility principle, you are guaranteeing that two functionalities are completely split into their own classes. Okay, there is no cross reference of functionalities here. So that's why this allows developers to work parallelly. So a person who is working on order service will continue his work on order service because he is not required to worry about email service. In the same way, a developer who is working on an email service is not required to worry on the functionalities or changes of order service. So that's what allows us to achieve the parallel development. Okay, so we can achieve the concurrent delivery here. or development, I can say. Cohesive libraries. Software units are easy to comprehend and are more reusable. A class that does only one thing and does it well is more likely to provide value in a different context than a class that aggregates many unrelated behaviors. Okay, mark this statement, guys. Okay, so software units are easy to comprehend. Comprehend means it's very easy to understand and they are more reusable. Okay, this email service you had written for your web application can be used for a console application. It can be used for a utility application. Okay, it is not tightly coupled. A class that does only one thing and does it well, okay, concentrate on this, is more likely to provide more value than a class which aggregates many things if we don't follow the single responsibility principle. So we will get cohesive libraries and which can be reused and they add more value to your product maintenance. Once we know that all our responsibilities are properly separated, it becomes very easy to do further enhancements to the product. We basically avoiding the problem of spaghetti code. One of the serious issue when we don't follow SRP is the problem of spaghetti code. Basically, you are aggregating many things into one class. So by following SRP, yes, we can achieve higher product maintenance because you are not required to worry about the regressions, okay, because your responsibilities are properly separated or segregated. So whatever change you do, only that class will change and only for that class's functionality. So that class has only one reason to change because the functionality of that class has changed. So this allows a good product maintenance. We don't introduce any kind of regressions. Okay, we achieve good unit of or good quality of unit testing, and yes, which allows us to have good product maintenance. Extensibility and scaling. Again, SRP allows extensibility to the granular level of class. Okay, because our classes are very easy to extend. If the functionality around that class is enhanced, then the class is also enhanced, thus not touching the unintended parts of the product. This level of extensibility makes the scaling of the enterprise product much easier. I hope pretty much clear. I think it's very simple. We can achieve the extensibility as well as scaling of our complex applications very easily. So I'd like to take one example now. I have created one order service, or you can say food order service itself. Okay, this is the contract I order service I have created. Now, what are the various steps involved in food order? Basically, first of all, we create the order. Okay, and then we execute the order, we track the order, we deliver the order, we send email notification for the order that we had created on various statuses or stages of that order, and then we finalize the order. At the first glance, it is very usual that this seems to be okay, but if we apply the concept of single responsibility principle, we will come to know that this particular interface is doing more than one responsibilities, or it has aggregated many responsibilities. Okay, and how can we split that? Okay, let's go to the next slide, and here I will explain the split. So when I apply single responsibility principle, see, look at the I order service contract now, or the interface you can see. See, I order service. The order service should only deal with order related functionalities. That is, create order, execute the order, and finalize the order. That's it. Okay. So, what is the single responsibility of I order service class or interface is to deal with the order related stuffs. Nothing else. You should not deal with the delivery related stuffs. You should not deal with the email related stuffs. You should not deal with the tracking stuffs because tracking is a different functionality. Delivery is a different functionality. Email is a different functionality, right? So when you apply single responsibility principle, I get these simple and smaller and much clearer and very functionality oriented small classes. That is, I order service is only dealing with order service, which is create order, execute order, finalize order. A delivery service only deals with the delivery of the order with the order ID. See the relationships now. Okay, the relationships are emerging now basically. Okay, now public interface, if you see the I email service, see, Email service is only dealing with email related stuff, that is send email notification whenever your order is completed or it is finalized. And iTrack service, it is only associated, or it is only concentrating on the tracking of the order with its order ID. I hope you people understood the significance of using single responsibility principle. Okay, so a class should have only one reason to change. So that's what we achieved here. All these four classes have their own reason, and whenever something changes with that reason or functionality, then only these classes will change. Okay, otherwise they will not change for any reason. Okay, and also they don't make other classes to have changes because we have properly segregated the responsibility. Okay, so this is the concept of single responsibility principle. I hope you people understood. Please do apply this single responsibility principle during the low level design whenever you start the development of your user stories or product backlog items. Okay, I hope the concept is clear, and that's it for the day. Thank you guys.